Moving on to example 3, we want to determine the power absorbed by our CCCS. In the circuit below, we have a 12 volt ideal source providing a potential to the circuit to our right. In between the node of our 2 ohm and our 2 and 4 ohm resistors, we have an ammeter that is measuring a current, I sub C, flowing through said short circuit of minus 1.2 amps. On the right hand side of our circuit, we have a CCCS where our output ID is equal to 4IC, where we have a voltmeter measuring the voltage potential across our CCCS. That value is 24 volts. Now, to simplify the circuit for analysis, we have to recall that an ammeter represents a short circuit, a voltmeter represents an open circuit, and we can redraw our CCCS as a short circuit. In doing such, we have the following circuit. Now, IC is equal to minus 1.2 amps, such that we do not have to solve for it, rather is given by the measurement of our ammeter. And ID is equal to 4IC. Thus, we can solve for our output of our CCCS, such that ID is equal to 4IC, or 4 times minus 1.2 amps, such that our output is minus 4.8 amps. Now, our voltage drop across said CCCS is 24 volts, such that when we calculate the power as our current times our voltage is equal to IV, which is equal to minus 4.8 amps, times 24 volts, which is equal to 115.2 watts. Now we know, based upon the representation of our voltage potential and current running through our CCCS, that the device is consistent with our passive sign convention.